And we are back in Better Than Ever in Chapter 10, where we're dealing now with empirical formulas and molecular formulas. In the previous podcasts, or in the previous notes, we were taking a look at determining the percent composition by mass of an individual compound. And now what we want to do is show you how we can proceed towards empirical formulas and finally molecular formulas. So the first thing we need to do is actually define what these things are. An empirical formula is simply the lowest whole number ratio of the elements in a compound. Okay, the lowest whole number ratio of elements in a compound, as opposed to the molecular formulas. The molecular formulas are the formulas you're typically used to seeing. The molecular formulas can tell you the actual numbers and types of atoms in a compound. Okay, I think it'd be a little bit easier if we did a comparison, and then I think you'll see the difference. It's actually a very simple difference between empirical and molecular formulas. All right, let's start off with a molecular formula. Start off with something simple. Let's go with, say, glucose. Glucose has a molecular formula of C6H12O6. All right, and most of you guys know that. However, the lowest ratio, or the lowest whole number ratio of these, is going to be found by dividing through by 6. They're all divisible by 6, so if we do that, you get 1 carbon, 2 hydrogens, and 1 oxygen. So this is the lowest ratio. This is the actual formula for that compound. Now, if we give you another one, let's say we go with, let's go with what's called benzene. Benzene is C6H6. It's a liquid. It's sometimes used as a solvent. But anyway, if you divide through both by 6, it has an empirical formula of CH. Now, if you take a look at what's called acetylene, acetylene has a formula of C2H2. This is a gas. It is flammable. It's explosive. Well, we'll just call it flammable. And it also has an empirical formula of CH. So here's the deal. You can have different compounds with the exact same empirical formula. That's okay. It's the molecular formula that tells you what the compound actually is. We use the empirical formula to get to the molecular formula, and we'll show you how we do that as well. Let's give you another one. You have, let's give you two here. We have N2O4. This is dinitrogen tetroxide. And then you have NO2, which is nitrogen dioxide. If you reduce N2O4, the empirical formula is NO2. If you take a look at NO2's molecular formula, you cannot reduce it anymore, so that is the empirical formula. So in some cases, yes, you can have two compounds that have the same empirical formula, but even more, you can have a molecular formula that is the same as the empirical formula. Sometimes it doesn't reduce. All right? I think you get the picture here. Let me hang on just for a moment. All right, I'm going to put up three molecular formulas here. Let's go with we'll go with vinegar, which is C2H4O2. It's actually acetic acid, but diluted it's vinegar. We're going to go with what's called formaldehyde, CH2O. Okay, that's used as a preservative. And let's go with diborane, which is actually B2H6, diboron hexahydride. And if you want to pause this, you can go ahead and you can work through, try to figure out what the empirical formula is for all three of those particular compounds. Okay, so assuming that you've tried those, let's go ahead and reduce those. C2H4O2 can be reduced down to CH2O. We've actually seen that one before. If you take a look at the very first one we did, glucose also had an empirical formula of CH2O. Okay. The next one is CH2O. That cannot be reduced any further, so we'll simply call it CH2O. And the last one, diborane here, B2H6, that can be reduced by 2, so we'll be left with BH3. Now, just one more note on a few of these compounds. Formaldehyde, which is CH2O, the vinegar, which is C2H4O2, and then also glucose at the top of C6H12O6, they all reduce down to CH2O. This is why we call all of these types of compounds carbohydrates. There is a carbon and then water, which is referred to as a hydrate. So carbon and water is the empirical formula for all carbohydrates. All sugars will have an empirical formula that is CH2O or very, very close to it. And so you have sugar, glucose, you have vinegar, and then you have formaldehyde, all having the same empirical formulas. Okay. Now you cannot, at least right now, go back the opposite way. I cannot at this time give you an example that gives you an empirical formula and you tell me the molecular formula. Although that is the natural order. Typically what we determine is an empirical formula, and then from that you can determine a molecular formula. In the next podcast, we're going to start to show you how you can determine an empirical formula. We'll see you next time.